All right. Hi, everyone. I hope you're doing fine. I'm doing fine as well. And it's been a few 2 weeks, a very nice 2 weeks of learning RabbitMQ. I thought that I'd do it in 1 week and finish the whole thing, but yeah, shock on me. It took me more than that. Definitely because of work and some other commitments, but it's been a very rewarding experience, to be honest. And I started a series which I know I won't complete, so I just decided to do a whole video that talks about RabbitMQ. Of course, in slides, and then I'll share some materials. The GitHub repository contains Markdown for the lessons, and also it has practical code. You can translate that, and I'm also currently building a project on it, so I'll share that as well so that you can go and look into it. Of course, next is gonna be Kafka. I hope so. Very, very lengthy thing to talk about. But yeah, let's see where this discussion leads us to. So, in the next few minutes, at least I've said here 15 minutes, we'll see whether we'll stick to that. But there are specific 9 lessons I'd love you to kind of understand when it comes to RabbitMQ. So, first is we do setup. We look at how a simple hello world setup would look like, work queues. So, when you want to distribute tasks, routing, Fanout, topics, publisher, confirming, manual acknowledgements, and then the very important one that you definitely want to use in production, the dead letter exchange. So let's get into it. So the core thing that you need to understand when it comes to RabbitMQ, of course, it's a message broker, and here we're talking about a smart consumer and a dumb broker, or a dumb publisher. Sorry. So a producer never talks to the queue directly. So how it happens is you have a producer, of course, publishing a specific event, and then using a routing key, it publishes that event or message to an exchange. So we have an exchange that sits in between, and then the queue comes after. This is where we buffer our events or messages, and then for the message to get to the queue, it has to be bound to that exchange by a specific routing key. So the producer has no idea who is listening, so that's a dumb producer. And then the binding is the only thing that decides the delivery. Of course, producer with the key goes to the exchange, to the queue, etc. And then every lesson changes one part of this line. So every lesson that will come across throughout this video, I would be changing just a simple thing across this line. So let's get into it. So how this would look like is we have a scenario where we have work that shouldn't block the response. You have to produce thumbnails at the same time, send emails, and do CSV exports. So for such a scenario, you need a competing consumer. So you have various consumers that would take in the messages, and then we'll definitely do a deep dive on this. And then we also have an event where many services need to react to. So it's kind of like a pub sub scenario where an order is placed, but you need an email to have access to that event, and analytics, and an audit. That's Fanout. And then you also need to route by service or severity. So here, every error, any service, and to the pager. So here we talk about direct and also talk about topic exchanges, and then payment and billing. So you losing a message here is not an option. The message has to be delivered. So here we're talking about confirmations. So where we have manual acknowledgements, confirmations, and whatnot. And then there are scenarios where you're using or integrating third-party APIs in your whole sequence. So what happens when a message or an event doesn't succeed during the first try? So we have the concept of a DLX, waiting, retry, and also packing. So I just a very short note is OpenStack runs its own the whole control plane on RabbitMQ. And also Celery. Celery is something that is related to Python. Django also uses RabbitMQ as the core messaging. Okay, so before you code, I normally advocate for this. You do a simple docker run command here. Of course, I've talked about this before. Do a simple docker run command, pull. Of course, this is supposed to be RabbitMQ 4 for management. You pull the image, play around with it in the UI, and get to see what happens. But the most important things that happen is we have two ports. One is the AMQP, so Advanced Messaging Queuing Protocol. This is where Spring Boot application connects to, and then 15672 is the management UI. So ideally, where the browser is at. So if you look at my previous videos, I was showing you a UI, and then we have the default credentials, which we definitely talked about. So play around with the UI, and then afterwards, now comes the actual code. So how does the topology look? So how is the flow of events? So for my repository, I use a monolithic application just to make things simple. But if you prefer to have separate applications, like kind of quote unquote microservices, where you have one being a producer and one being a consumer, you'd have to set things up. So in your config file, this is a simple hello world. We have a queue. So queue is where the message would be published. So of course it needs a name. Sorry, I didn't include the name, but this could be any hello world.queue, something like that. So this is the queue, this is a static name. And then we also have another bin for exchange. So there are 3 bins that we need to define. One is a queue, the other one is an exchange, and then the last one is a binding. And then how you bind the two is you pass in, you can do parameterized, or you can pass the bins created and whatnot. But the core thing is you bind a queue to an exchange with a specific routing key that you define in your file. And then the producer, this is gonna be the same code over and over again. Nothing pretty much changes. Okay, so you just need a Rabbit template, use constructor injection, of course, and then you need a send method. And then it doesn't necessarily have to take a string. You can take whatever payload, and then you do Rabbit template, don't convert and send, pass an exchange. So whenever you're publishing a message, so this is convert and send is publishing a message, you need the exchange, you need the routing key, and then you need the specific payload that you're sending. And then now to the consumer, this is how it would look like. You just need one thing. Of course, it's a component, and then you just need this annotation called @rabbit listener. And which queue is it listening to? It's listening to this queue here, and they need to be identical. And then yeah, you receive the message and then do whatever it is you want to do with it. There's also the concept of work queues. So here you have one queue, but we have many workers, and all the workers are competing for tasks that are published. So think of the scenario we gave. So you just have like one path. An event happens, and then you're supposed to process a thumbnail, generate a report, and all those things. So how that would look like is when those events come, they go to one queue, and then this queue needs to distribute these messages, because we don't want to processing a PDF to block sending an email or something of the sort. So if you're thinking in the concept of work queues, so how this would look like is you have workers. So workers are ideally just consumers, and we'll see how that looks in code. So, and then the very important thing is, of course, the same thing remains. Like I said, you have a task producer, the specific work, exchange, work queue, and then publishes the whatever here, the events. Now, the worker 1 would do something, and then worker 2 would do another thing. They won't get a copy of what is happening, so they get different. And then there's a concept of a prefetch count. Here if you put to 1, that is a fair dispatch. So if you put a prefetch count of something like 5 or 10, they definitely result, or if you don't put a prefetch count, they'll default to a round robin. And a round robin means that if you have one worker being slower than the other, it doesn't matter. The queue doesn't matter. It will always assign the same amount of tasks for both the queues. Doesn't matter if it's slow or if it's fast. And yeah, so even if a worker dies mid-task, the message still comes back to it. So that's pretty much very bad. Okay. And in terms of code, this is how it looks like. So we have a factory. So you have to create a simple Rabbit listener connection or container factory, and then it takes a connection factory, and then you just need to do a bit of wiring here. First is you set the connection factory to whatever factory we passed, and then you need the acknowledgement mode to manual. So the listener or the consumer is the one who would pass the acknowledgement if it happens or not. A prefetch count of 1 so that we have a fair dispatch. So you just get one task. The worker gets one task per event until it processes the whole of it. Now, the thing that changes on this side of the consumer is that we have queues. Yeah, Rabbit listener, of course, the queues is work queue, and then we have a container factory. So the container factory needs to be this exact bin name. So the bin name for this, because we haven't provided, it would be derived from this method. It's gonna be work, and ensure you get that right, or you can specify the bin name. And then concurrency we set to 2. So this means that while we process this here, the specific messages, we're gonna have 2 process task thingies. So we're gonna have 2 of them. Now, because we are doing the acknowledgement mode to manual, we need a channel. This channel will enable us to send an acknowledgement once we've done the whole processing. And then you also need a delivery tag. This is quite important when the task won't succeed and you have to requeue the message. So it needs a delivery so it knows where to go once it's requeued. The other bit now is we have 3 exchange types. Of course, talked about exchange types in a previous video. We have Fanout. Fanout is when various services, it's kind of like a pub sub, when various services need access to that specific event. A user signed up, an order was created, for example, you need an emailing to tell them that their order is being processed, you need an analytics for your own processing and whatnot, and then you also need an audit queue. So Fanout ignores the key, and very important is as you produce the message, when you do RabbitMQ.convert and send, you need the exchange, and then where the queue is, you just leave the quotation marks. If you don't, that message is going to be dropped. We have direct. So here we are doing what we call exact match, and nothing else is delivered. If it doesn't match, for example, you're publishing with error. So if you do something like a debug and it doesn't match any, you definitely get the message being dropped, and you even won't notice. The other bit is now topic exchange. So this one is very interesting. I guess this is one of the most common ones. And how it looks like is, sorry for that. Yeah, how it looks like is you want to pattern match. So there are scenarios where you want a generic log of all the activities, and there's scenarios where you want payments to go to a specific queue, errors go to a specific queue, and then you have one that takes everything. So if you do a payment.error, if you publish a payment.error, hash.error, hash means, we'll talk about it in the next slide, that would go there. So let's actually get there. So if you do a payment.error.critical event, this is what is published. So point to note, star takes one word, hash takes any amount of words. So if you have payment dot hash, it means it can be payment.error.critical, payment.debug.anything. So hash takes, so this one matches. So this payment.error.critical matches this pattern here. And then payment.star. So this means that we need only one word. So it could be payment.error, that no critical, no additional words there. So that is no match. And then payment.star.star, it means we take 2 additional. So 1 word for each pattern. So payment.error.critical, payment.error. I don't know, something of the sort. And then hash.critical, it means that it needs to end with critical, and then it can take any amount of words before it. So this matches, and then hash matches absolutely everything. Okay, and then we also have 3 patterns. Of course, just pretty much from what we've talked about, how it looks like in code. We have a queue for critical things, so all the errors from any service. So this is what happens. So with a key hash.error, so any error is gonna be in this queue. We also have all the payment logs of any level. So payment.hash, payment, any payment, whatever, payment failed, payment created, all of them would pass into there. And then, but for this case now, it's just like logs. Okay, payment.error, payment.something, and then we have the one with the hashtag here, and then this pretty much takes everything. So for example, we do a payment.error. So this is the published key. So this payment.error would go to here because it ends with error, that matches that, payment dot matches that, and then hash. So that one would go to critical, payment, and all of them. If you look at auth.warning, auth.warning, we have hash, so anything could come, hash, and error. So it needs to end with error, so it won't go here. We have payment, this doesn't start with payment, and then we have hash here, so it's gonna go there. And then we also have this other one, payment binding. Okay, payment.info. So where does that go? So it starts with payment, goes there. It won't go here because this ends with info. Okay, but it will also go here. Orders.error, orders.error. So here error, and then hash to all of them. So one message can match several bindings and gets copied to each. Very important. So there's the thing we call fire and forget, where RabbitMQ just publishes a message and then it forgets about it. So when you do convert and send, so it just tells you nothing about what happened next. So there are things that are captured here. So the broker never got it. You don't know if the broker got it. The broker got it but could not store it for some reason. Maybe it got it but it didn't match any key, routing key, didn't match any routing key. And then there's a sneaky one. So it was accepted, routed nowhere, dropped without an error. So this one is the scenario where the routing key does not match. So these are the simple questions that are asked. So we confirm, did the broker accept it? If the answer is yes, you fire. And then there's a return now. Was it routed to a queue? So if it wasn't routed to a queue, you return the message. So a message can be yacked and returned at once. You want both on, very important. So how we achieve this is we set callbacks. Of course, we look at callbacks. If you want the publisher to confirm, you have the correlated type. So this means that whenever a specific message is not accepted or is to be returned, there's a correlation. So each message would have a correlation ID. And then publisher returns true. So this means that the message can be returned back. So correlated helps you know which message the acknowledgement belongs to. So that's very important. And now the Rabbit template, for this you need a Rabbit template, a simple Rabbit template. So we not use the one that's provided for us by Spring. And then there is this. So every message needs an acknowledgement. So you set a confirm callback, of course, with the correlation ID, the acknowledgement, and the course. If the message was not routed, if the message was accepted but it was not routed, we need to set returns callback. And then while this message is returned, you can do anything. You can get the routing key, you can republish it, you can do whatever you want to do. But for this to be enabled, you have to set mandatory to true. Rabbit template.set mandatory to true. Otherwise, your message is gonna come back and then it's not gonna come back, actually, it's gonna drop. So you need to set that. So how you tag it so that you can match the acknowledgement is when you click on publish, we have a routing key, a specific message, of course, when you're publishing your message, and then voila, you create a correlation. So you need a correlation data. So this is just going to be a random. Every event gets a random UID. Exchange, the routing key, the specific message, and then the routing. So if order is created, binds, matches everything is okay, fantastic. If you publish an event order cancelled, there is no binding for that. So we acknowledge that the broker got it, but now it hasn't found a place. Okay, so we have to return it. Otherwise, the broker might accept it and then it threw it away. This is if you didn't set this mandatory to true. Okay, so we also have the concept of manual acknowledgement. So this is just to ensure that every message gets home, so that we don't get messages being dropped and whatnot. So you have wrong, you just like have one way that is wrong, you lose the data, and then you have another wrong way and you loop forever. So looping forever is when you requeue a message that can never succeed, and this would lead to a poison message. And then you drop what failed transiently. So just like a simple failure could be a network connection with your third-party API implementation. So if you don't handle this scenario nicely, that means that your message would drop. It could be a payment process and whatnot, and then the redelivered. This is where you perform the retry. So we'll talk about this as well. So you have a basic AG, and then it comes with a tag. So if you look at this other previous code, no, we haven't looked at that yet. Yeah, so a basic ACK, this is a basic acknowledgement. This is how you acknowledge, and then you set false to requeue false. That means if the message is processed, so it's deleted from the queue. Requeue to true, this means that the message failed. Let's try again. This is very dangerous if the message would keep on failing. And then requeue to false, this means that don't repeat that, don't requeue that message, just drop it. And this is very, very, very bad. So how do we do in code? So for this piece of code, we have a requeue where we'll be doing it once, and then if we process it again, so that means it's been redelivered into the queue, we just drop it. Of course, that is not the best way. We need to use a DLX for that. So also we need a container factory because we are doing manual acknowledgements. Okay, and then a channel to enable us do the acknowledgement, the basic ACK, and then every message needs a delivery tag, and then we also need this tag for a redelivered, just to tell us whether this message has been reprocessed again in the queue. If everything goes okay, we pass the delivery tag. Of course, we acknowledge and then pass the delivery tag, and then false, we don't requeue it. But if the message failed, this is the first failure, could be a network issue or something, we set a requeue to true, so we requeue, it goes back to the queue. But if now it is redelivered, now if it's taken back to the queue, it will be redelivered. We just stop the loop and the message goes. Okay, because if I'm retrying it for the second time, it means that it will continue failing possibly. But for us to handle this in the best way, we need to do what we call a dead letter exchange. We need to introduce a dead letter exchange. So there's no DLX type. This is very important. So DLX is not like a specific exchange type. It's just a direct exchange type, but with additional attributes. So the name describes how a message arrives, not what it is. So it's not like an exchange on its own. So how you configure in the source queue, you add an X dead letter exchange, of course, with an X dead letter routing key, and then also a TTL. You need a TTL on the next queue that is going to send it back. So various things might happen. Could be a network issue, could be a poison message, and how retries, you also put like retries for the specific messages that are failing. So you could have like 5 retries and whatnot, and then see how it goes. So you have a main DLX. So this is what I was talking about. Of course, it's like notification queue. You use a queue builder. So durable, you set it to durable, which durability, of course, coming from the notification queue, and then with an argument. So this is the argument X letter exchange. This is the notification DLX, and then also pass the X letter routing key. And then after that, that is the main queue, the main DLX. We also have the wait queue. Now this queue, what it's gonna do is it's gonna store the message. It's gonna act like a graveyard, temporary graveyard for your messages. So it has a TTL of, say, for example, 5,000 milliseconds, and then goes to a dead letter exchange, and then X dead letter routing key. So what happens is, if you retry your message, and then you don't want to spam your DB, so anytime you want to retry your message, comes to this queue, it's published to the, wherever it fails, it goes back to the notification queue, wait queue, waits for some time, and then it's reprocessed like that. So that's just like a temporary storage location for your messages that fail. And then in the consumer side, you'll have to configure this. There's a tag that you want to append on every event if it fails. So you have a rejected count. Of course, this is just like some logical processing. For every stream, of course, it's a list, and then you filter by notifications queue. You get the queue like that. So you filter. And then, so this is gonna do is gonna get you the count of the number of times this message has been requeued or retried. So if you set to 5 and it's past 5, there's something you need to do about that. So we get the rejected count. So this is where the notification consumer is at. And then if everything goes well, we acknowledge. And then if the retries is surpassing the maximum retries that we'd set, we don't requeue it, and we do something. Okay, so how we do that is, what we do actually is we send it to what is the name? We send it to a queue. It's called I'm forgetting the actual name. We send it to a queue where a human now would have to come and do like some intervention on it. So out of retries, when it's out of retries, you publish it to a packing queue, and that is where somebody on your team would have to come and look at it. Last but not least, now it's time for you to go and break the whole thing. You go kill a worker mid-task. What you should see possibly is the unacked message goes back to the queue. You restart the broker. If you set the messages to durable, you'll definitely see them. If you set the messages, the durability to false, you're not gonna see them. Publish 10,000 messages and then watch the memory climb in the UI. This is fun. publish an unrouted key. So this is gonna be in silence. The message is gonna disappear, and then send fail 4 times. This is documented in the README, so you can go check it out as well. So that you try and have fun with it. So this is what you need. Set up, play around with the UI first, mess around with work queues, check the routing, try fire and forget being a lie where you have to have a confirm, try the DLX and you'll be good. Also talk about Fanout topics and the manual acknowledgements, and everything would make sense in RabbitMQ. So that has been my experience. I have an understanding of how things work now. I'm trying to implement it in a project, and that's the kind of the best way to learn about it. So the project is publishing events or correlated events. I use Saga, Outbox, and just try to have fun with how things work. So yeah, that's the 9 lessons you need. Now go break something. So if this was helpful, comment, like, the repository is here, and you can definitely have fun with it. Lesson 10, I'm not sure whether I'll do the RPC, reply something, but it's gonna be fun. Let's see how it goes. Okay, thank you so much for watching up to this very end. I hope you learned something, and let us know your experience with RabbitMQ. Till next time, bye.